Roads crack, runways rut, parking lots turn into pothole bingo. But before any asphalt gets poured, there's a simple number that predicts how that surface will hold up. The California Bearing Ratio, CBR. Hook. Imagine pressing your thumb into a sponge versus a brick. The resistance you feel? CBR measures how hard it is to push a standard plunger into soil or base material compared to a crushed stone benchmark. Higher CBR, stronger support. Lower CBR, you'll need thicker pavement or better soil. Explain. The test is straightforward. You compact a soil sample to a target density, often at optimum moisture. Sometimes it's soaked for 4 days to simulate worst-case wet conditions. Then a piston presses in at a constant rate, 1.25 millimeters per minute. You record the load at 2.5 millimeters of penetration. You record the load at 5.0 millimeters of penetration. CBR is the ratio of your load to a standard load times 100. So if your sample needs half the load of the standard, CBR is 50. If it needs 1/10, CBR is 10. Typical ranges: soft clays might be CBR 2 to 5, silty sand maybe 5 to 15. Well-graded gravel could be 30 to 80 or more if it's dense and dry. Designers usually pick the soaked CBR for conservative pavement thickness. Field shortcuts exist. The dynamic cone penetrometer, DCP, correlates blow counts to CBR so you can profile strength with a handheld tool. It's not perfect, but it's fast and great for spotting weak layers before they become expensive surprises. Apply. Here's a quick mental model for flexible pavements. Lower CBR means thicker structures. For a light-duty lot at CBR 5, you might need a robust base and sub-base beneath the asphalt. At CBR 20, that thickness can shrink significantly, saving cost and time. The exact numbers come from design charts, like AASHTO or local standards, but the trend is reliable. 3 practical steps you can use this week. Sample smart. Test at in situ moisture and density. And soaked. That gives you best case and worst case. Control compaction. A bad soil compacted well can outperform a good soil that's loose. Verify with field density tests. Fix the weak spots. If CBR is low, consider lime or cement stabilization, geogrids, or simply over-excavation and replacement with a stronger granular layer. Common pitfalls? Assuming dry season CBR all year. Moisture swings can cut CBR in half. Ignoring variability. One test isn't a whole site. Take multiple locations and depths. And mixing fines into your base during construction. Contamination can tank your CBR. Let's wrap with a quick scenario. Your subgrade tests at CBR 4 soaked. You run a DCP and find a soft lens at one end of the site. You over-excavate that lens. Place and compact a crushed aggregate subbase to CBR 40+. Then design the asphalt thickness off the subgrade CBR. Result: a uniform platform. Predictable performance, fewer callbacks. CBR won't build your road, but it tells you what your road needs. Get that number right, and everything on top lasts longer.